So we learned about all these hooks. Now let's see what they actually do. In the server element component, this is the component I will choose for demo purposes. We already get the constructor and ng on init. So in the constructor, I will simply log constructor called so that we can see when this happens in the console. And I'll do the same for ng on init, but of course here I'll say ng on init called. Of course I will add the other hooks then too, but let's start with these two. And if we reload the application here, we see right at the top constructor called ng on init called. And for every new server we add, we see this again, of course, because a new instance of this component was created, and therefore all these hooks are executed again because it's a brand new instance, doesn't have anything in common besides the class it was created of with the first instance of that component here. So that is constructor and ng on init. Now I told you that ng on changes would run first. So let's implement ng on changes, and this would be enough, though it is a good practice to implement the on changes interface too, and that is true for all hooks. Implementing the method alone will do the trick, but it is a good practice to be very explicit about which interfaces your component uses or which methods your component will have. So therefore implementing these interfaces is a really good practice. It's very clear then which methods may be called in your component and which methods you won't have. Now here we're getting a lot of imports, which is why I will split this up. And as you can already see, you have to import all these interfaces on init and on changes. So ng on changes runs first, as I told you. So let's say ng on changes here. And this hook here actually receives an argument. It's the only hook that does. Here we receive a changes argument, which is of type simple changes, which also needs to be imported from @AngularCore. So I will simply log changes here so that we can have a look at it and see what's inside. So let's save this. And here at the top again we see constructor called ng on changes called, as mentioned before ng on init. And then we see the simple changes. That's an object which has element, which is of type simple change. An element, of course, is our bound property. Here, it's this property name. That's the name we see reflected here. And then Angular simply gives us some information. What's the current value? Well, that's this object with just a test server, and of type server. Is this the first change? Yes, it is. We just initialized it. And what's the previous value? There is no value because we didn't change this before. Now to see that ng on changes actually gets fired more than once, I'll add something to this app just for demo purposes. I'll add a button, change first element, to my app component template above this list of server elements. Give it some bootstrap styling here, but that's not really important. More important, give it a click listener. On change first would be a name you could choose. And then in the app component TypeScript file, I want to change the name of the first element. Now for this, I also need to change the way we pass this element to the server component. Right now, we receive the full element, the full object, and I will leave this here for demo purposes, so that we can reference this code. But now I only expect to get the name, because the name is the only thing I'm outputting here anyways. So I'm duplicating this and I will comment out the old code. And now we only output the name, because all the other element information was projected via ng content into this element anyways, into this component. So we only get the name now. This name will simply be a string. We added input so that it can be bound from outside. And we're outputting name here. So in app component, when we loop through this, I will now actually bind the name to, and I will bind to server element name. And we wouldn't need to bind server element here anymore because that is not used, but I will leave it here for reference. So this is now how we pass the data, how we pass the name. In the app component TypeScript file here in onChangeFirst, I will now access my server elements, the first element, and therefore this will fail if we were to empty this array, and set the name to changed. So again, I did these changes so that we can really see when ng on changes gets fired. And we couldn't use the element as an object because objects are reference types. So we passed the object via input. Therefore, both properties in the server element component, this one here, and the object in the array of server elements here in the app component, they both point to the same place in memory. And therefore, if we change the name there, it will update in the child component, in the server element component, but it will not trigger ng on changes, because technically the property we're binding to, we use here with add input, that didn't change, the value of that didn't change. It's still the same object in memory. So it's simply this difference between reference and primitive types. And you should look this up if that's all brand new to you. It's a JavaScript concept, has nothing to do with TypeScript or Angular. So that is why now I'm binding to a primitive with name, which is just a string, and therefore ng on changes should get fired again if I click the change first element button. Let's do that. And indeed, it does. Note that constructor and ng on init weren't called, but ng on changes was, and here now we also see the previous value and the new value. And therefore this hook could be interesting to you if you want to react to any changes and then do something with the old value, store it before it gets dumped or something like that. That's ng on changes. We get a couple of other hooks, so let's move on. Besides ng on changes and ng on init, we get do check. And as I said, this also needs to be imported from @Angular core. This will give us a method which is executed on every change detection run. So ng do check is the method we need for this. And here we can simply console log ng do check called. So let's see when this gets called. If this reloads, you see it gets called right at the beginning, then one more time here, but that is only because we're running in development mode. There, Angular has one extra change detection cycle. But it also gets called if I click this button, as you can see, and if I click this button a couple of times here. So ng do check, as I told you, gets called whenever Angular checks for any changes. And there are a couple of triggers which trigger this method. An event was called by clicking, or a promise gave us back some data. So a lot of triggers for ng do check. So that is not something where you want to run amazingly powerful code in, because that will cost you a lot of performance. But the fact that change detection runs as often as it does on its own is not a problem. And this can be a great hook if you want to check if you do need to change something manually because Angular didn't pick it up or something like that. So the next hook is after content init. This needs to be imported from @Angular core 2, this interface. And with that, we need to implement ng after content init. Now let's call this console log ng after content init called. If we do this here, you will see that here it is, there it is called after do check, and it is called only once because it doesn't get initialized again. Remember, content is the thing we projected into this through ng content, so this here will be our content in the end. Let's move on. The next hook then is, and this is getting long here, so I will split this up over multiple lines too, all these interfaces I'm implementing. So the next hook will be after content checked, like this. This also needs to be imported from @Angular core, and it requires us to implement a method ng after content checked. And well, now I'm just going to copy the code from after content init and replace init with checked. If we save this and have a look at it, you see here it is called, and here it is called again after do check, which makes sense because it is called after each change detection cycle. Well, now I'm going to copy these two here, and also I will add two new interfaces. The first one being after view init, and then after view checked. Both need to be imported from @Angular core 2. Now these require me to have ng after view init as a method and ng after view checked. And I will replace the text here in the console log so that we can see when these get called. So if we log this, you see it happens after the content has been checked. Well, and with that, we're almost at the end. The remaining piece is ng on destroy, and on destroy is called, well, right before this gets destroyed. This component gets destroyed. So let's add it here on the implements list, on the interface list, I should say, and make sure to add the import from @AngularCore. And then you need to implement ng on destroy here, and here I will say ng on destroy called. Now, to be able to actually see this being destroyed, I will add a new button destroy first component. Give it a class of button and then button danger to make it red. And here I will add a click listener on destroy first. I will copy that, add my method here in, just on destroy first, of course, just the name. Will add it here to my TypeScript code, and there I will simply call server elements the splice method, splicing at the first element and then just one element, therefore removing it. So with this, we should now see all the hooks called, view checked, and so on. And if I destroy the component, you see ng on destroy was called because we removed it from the array. Therefore, ng4 reran and didn't render this first element because it was removed. Therefore, it was removed from the DOM. Hence, this component hook was called. So these are all the lifecycle hooks in action. You rarely need to use all of them, but some of them can be very helpful for your application to hook into a specific piece, a specific phase, and run your code.